Okay, everyone, today we're going to talk about circles. So, of course, by definition, a circle has a center, and then every point on the circle is the same distance from that center point, right? That's basically the description of a circle, where the distance from the center to any point on the circle is called the radius. So if we wanted to know the equation of a circle, notice what it is. It also is just the Pythagorean theorem. Because remember last time we were talking about how the distance formula is basically just the Pythagorean theorem? Well, on a circle, all I need to know is this distance. If I know the distance of the radius of a circle, then I know where all the points are. And if I know the coordinates of this point, which that point we're going to call HK, then I can use the distance formula, right? Remember how the distance formula looked? It looked just like this, except because we didn't want the distance to be squared, we just put a square root over it, right? So it's the same formula. And in reality, it goes back to the Pythagorean theorem, which we can see real clearly if we imagine that the center is at 0, 0 on our graph. Then if this is 0 and this is 0, look what we have for our equation of a circle. Literally the Pythagorean theorem. Okay, so keeping that in mind, let's practice writing. This is called, we've got two forms of an equation of a circle. And this is called the center radius form, where we see the center and the radius. Okay, now imagine something else I could do with this is I could multiply these out, right? And have x squared minus 2xh plus h squared plus y squared, blah, 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 blah. Okay, so that's called our general form or standard form. So we need to deal with that also. But if I can get my equation in this center radius form, boom, I know everything you need to know about the circle, because this right here is my center and there's my radius. Okay. So the first questions ask us to just find the center radius form of each equation that's described. So now recall that let me write the center radius form down here for us. A squared plus b squared equals c squared, basically. Okay, where the point HK is the center. And of course, R is your radius. So notice I have the opposite signs here. The center is actually H. So right here, if my center is -3, there's a negative as part of my formula. So technically, it would need to be written like that, right? X minus, and then my coordinate. So really, we can just say, oh, I'm just going to change the signs. And when I pull my center coordinates out of the formula, I'm going to change the signs. When I'm putting them into the formula, I'm going to change the sign. So notice this is how that would wind up. Now, we've got plus y minus 4 all squared equals, and 6 squared is 36. There's the center radius form of the circle with these specifications. Okay, on this one, I would have x minus 0, technically, plus y minus 0 all squared equals r squared, Or, since it's minus 0, we can just say, oh, that's x squared plus y squared equals 9. So circles in the center radius form, extremely, extremely easy. Okay, I know everything about this circle from looking at these equations. Here's my center of this circle is at negative 3, 4, and it has a radius of 6 because this is the radius squared. So if I know that information, I can also quickly graph from that information. So notice this is the answers we got on the previous example. So if it asks me to graph this, first thing I need to know is that my center of this circle, like it had given us, is negative 3, 4, and the radius is 6. So I need to find where negative 3, 4 is. Okay. Okay, negative 3, 4, right here. Now, I'm not going to put a point there because technically the center is not a point on the circle. But if I know my radius is 6, then I can't go 6 this direction, right? That means 6 units in every direction from this point is on my circle. But when I go at an angle like this across my grid, okay, think about each grid as being a square where this is 1 and this is 1, but across here is not 1, right? That's square root of 2. Okay, but I can go this direction, 1, 2, 3, 4, 5, 6 units. This direction, 1, 2, 3, 4, 5, 6 units. This direction, 1, 2, 3, 4, 5, 6 units. This direction, 1, 2, 3, 4. I got off, I think. 1, 2, 3, 4, 5, 6 units. And all of these are points on my circle, so I could just connect them with at least a circular shape, right? We'll just imagine it's a circle. Okay, so same thing here. What this tells me is that my center is at 0, 0, and my radius is 3. So it'll be a little easier to graph since my center's at 0, 0. Okay, that's not a point. Okay, there's my center. So if I go 3 units this direction, 3 units this direction, 3 units this direction, and 1, 2, 3 units this direction. Okay, I messed up there on that little point. I don't want you to think that. I can just take it off, yeah. Okay, then I can connect my dots with a supposed circle. Okay, so the center radius form, easy peasy, right? As long as we memorize that form. However, well, okay, they're going to talk about something else before we get to the general form. Then this is something to think about. So let's look at our general form. I'm not sure why they put a C there instead of just R squared when it says if R squared equals C. So whatever. But think about this. C represents the radius, basically, right? C is representing the radius. So if C is a number greater than 0, then we're going to have a circle, right, that has that radius, whatever it is. But what if C actually equals 0? Then instead of having a circle, we simply just have that point right there. If we know if that's the center, but it doesn't extend it and have any distance in any direction, it's just the graph of a point. If C is less than 0, that would mean a negative number, Well, you can't have a distance that's negative. So that would mean that there's actually not a circle associated with that equation, right? That graph would be non-existent. Okay, so remember we said it's really important to be able to determine what kind of equation you have to know what to do with it. And so if I know this is the equation for a circle, it's way easy. Put it in center radius form, and I've got my center and I've got my radius. But how do I know it's the equation of a circle? Okay, I'm going to have two variables this time. So far, we've only worked with equations that had one. I'm going to have two variables, and there's going to be an x and a y with an exponent of 2. Not just an x like a quadratic, right? An x and a y. So once I see that, that's my clue that, this is a circle. So for example, the equation could look like this, and more generally will look like this, right? Generally, we have everything multiplied out, but how do I know what to do with this? Oh, it's got an x and a y, and they're both square. That means it's a circle, at least for this course. Technically, there are ellipses and hyperbolas that follow that format too, but we don't talk about them in this course. But those are circular things, right? An ellipse is just an oblong circle, and a hyperbola one cut in half and flipped over. So in this course, though, I'm just going to say, oh, if I've got an x and a y and they're both squared, I'm working with a circle. So if I'm working with a circle, I need center radius form. If I have center radius form, I know everything there is to know about it. All right, so how am I going to get center radius form? Let's look at it. Okay, it's going to involve completing the square. So you might want to keep up with these steps somewhere. Notice I don't have them written on the slides. Okay, so first thing I'm going to do when I'm converting, once I see that I have a circle and I know it's a circle, I have x squared and y squared, I'm going to combine my x terms together and my y terms, which this one already does. Generally, you'll see the x squared and the y squared together, and then the linear x, linear y, and that might even be on the other side, right, the constant term. But if they're not already in this order, I'm going to put them, my x's together, my y's together, and I want that on the other side because I'm going to complete the square on this, right? That's what my goal is, to look like right? Oh, good grief, sorry. I want it to look like this, which means I want to take this and add a number here. Remember when we did the steps for completing the square, so that I can write it as something all squared. All right. So first step is I'm going to rewrite it with my x terms together and leave a blank because I'm going to have to add a number in here. And then my y terms together, and I'm going to leave a blank because I'm going to add a number in there. And then I'm going to move the constant to the other side. Remember, our first step in completing the square was move the constant to the other side? Okay, so I'm going to do that. And then, okay, I'm going to complete the square on the x values. So remember our steps for completing the square. And by the way, well, I sort of say your coefficients here will always be 1 if it's a circle. If they're different numbers, that's what makes it oblong and ellipse shape. But we could have a number that I could divide out, but these would have to be the same number so I could divide it out. But I want this number to be 1 because I'm completing the square and because I want it to be a circle. Okay, this one, it already is 1. So our next step for completing the square is take half of this number, so half of 6 is 3, and square it. Let's add that to both sides. Okay, then I'm going to do the exact same thing for the y values. I'm going to take half of 10, which is 5, and square it. I'm going to add that to both sides. The reason I did that is because that makes this a perfect square trinomial, that I know how it factors. It's going to use this sign, and that first number we got, the half of 6, all squared. Same thing with this one. It's going to use this sign, and that first number, the half of 10, which is 5, all squared. And then equal, I'm just going to have to add these together. Well, it's negative 18 plus 9 is negative 9, so 25 minus 9 is 16. So there is the center radius form of that circle. And now I know that the center of that circle is at 3, negative 5, and it has a radius of 4. So I could also easily graph that if I needed to, right? I just come over here, I find the point 3, negative 5, and then I go 4 units in each direction. Okay, let's try that again. It's just the same thing as completing the square. Okay. All right, first step, I rewrite my equation and combine the like variables. Leave a space because I've got a number I'm going to add in there. This number's already moved to the other side of the equal sign. The constant's already over there, so I'm good with that. Now notice on this one, the leading coefficient of my square terms are not 1. So I have to get rid of, and in an R set here, they'll be the same number, so I can get rid of both of them at once, right? If they're not the same number, it's not a circle, but all we're going to have are circles. So I'm going to divide everything by 2, all the way across, dividing everything by 2. So I'd have x squared minus 3x plus y squared plus 5y, okay, equals 1. Okay, now I'm going to complete the square on each one of these. So I need to take half of 3, which is 3 halves, right? Remember? Half of 3, multiply straight across, is 3 halves. And if I square that, I'm going to get 9/4. That's what I'm going to add to both sides. Plus 9/4 plus 9/4. Okay, now I need to take half of 5. So half of 5, which is 5 halves, and square it. That's 25/4. Add that to both sides. Okay. Now the reason I did that is because I know how this factors now as a perfect square trinomial. It's going to be x, use this sign, and this first number we came up with, 3 halves, all squared, plus y, use this sign, and the first number we came up with, 5 halves, all squared, equals, now I need to know what this is, so let's go back and let's change this 1. These already have the same denominator, so let's change this 1 to a denominator of 4, which means it's really 4/4. Okay, now that they all have the same denominator, I can keep that denominator and just add all the numerators. So 25, 29, 38 over 4. Okay. Okay, so there's your center radius form. And if I needed to know now, I know that the center of that circle is 3 halves, negative 5 halves, and the radius is the square root of 38 over 2. Okay. All right. One more time, really, this one's giving us a little hint, but it's telling us that this equation here isn't actually the equation of a circle, but they want to know, is it a point or is it non-existent? Well, we may not know until we get our completing the square finished, even if it's going to be a circle, because we probably won't be told, hey, this is a circle in general. So let's look at how do we know. So same thing, I know, hey, it's a circle because I got an x squared and a y squared. Well, I know it's saying it's not a circle, but we're saying, okay, this is the equation for a circle. If I want to deal with it and be able to solve it, which means solving a circle means knowing what the center is and the radius, then you know about that circle, okay? Then I need to put it in center radius form, so I need to complete the square, which means I'm going to gather my x terms together, leave a space, and then my y terms together, leave a space, move the constant to the other side. Okay, leading coefficients are already 1, so I'm good with that. So to complete the square, I take half of 10, which is 5, and 5 squared is 25. Let's add that to both sides. Half of 4 is 2, and 2 squared is 4. Let's add that to both sides. Now, that makes these perfect square trinomials, and I know how they factor. It's going to use this sign and that first half of 10 number, so 5. This one's going to use this sign and that half of 4 number, which is 2. And then if I add these together, notice that I have, well, here's 29 minus 33, so I have negative 4. So there's my center radius form, but because this number is negative, I can't have a negative radius. That means this circle is non-existent. This does not make, you cannot graph a circle from it, right? Okay. If this would have been 0, then I would have said, oh, I have a point. For example, let's say if we had, x plus, when we got finished completing our square, I would say, oh, this is no circle, but it does, I could plot a point. This is the equation for the point negative 5, 2, right? Radius 0. So in other words, not a circle, no radius. Okay. All right, let me know if you need anything. See you next time.